Bismillah ar-Rahman ar-Rahim. Temperature, the concept of temperature. Temperature rises as heat energy is added. This is the same way as the concentration is being increased by adding a solid to a solution. Temperature of a gas is a measure of its speed. Temperature scales, mercury, which is used as a method to measure measurement, depends upon its increase in volume whenever it's heated. Then this is the basis of the Fahrenheit scale. The SI system of unit of temperature is Kelvin, which is defined as the fraction of 1 over 273.16 of the thermodynamic temperature of the triple point of water, TTT. At this point, all phases, which is solid and liquid and vapor, are in equilibrium regarding pressure. Temperature equals the Celsius plus 273.13 of Fahrenheit to give me the temperature in Fahrenheit. The triple point of water occurs at temperature of nearly 0.01 degrees Celsius. We have number 3, non-electrical techniques of temperature measurement. First of all, we have the mercury thermometer. As we said before, change of volume of it due to temperature, and there is an angulated constriction, as you can see in the course of the thermometer, to split the mercury column after it has reached a maximum reading, and then the only way is to check so that the mercury can come back to its bulb. Of course, the drawbacks of it, of course, it is difficult to be introduced in the rectum during putting the patient in under anesthesia, and of course, it takes a long time to be recorded within 2 to 3 minutes till equilibrium occurs. The second thermometer where we can use is alcohol. It solidifies at minus 39 degrees Celsius and boils at 78.5%. This why it makes it difficult to be used in high temperature situation. Of course, the disadvantage of it is non-linear as regarding its course as compared with mercury. The dial thermometer, we have 2 types of dial thermometer. We have the bimetallic strip, which is made of 2 strips of metal. These are attached to each other, making a coil attached to a pointer on a scale, as you can see. And this is the sensor. The 2 metals have different coefficient of thermal expansion. That means that whenever it's heated, one of them is more expanded than the other. This is why it creates a movement of the pointer over the scale or on the scale. The second method is the boarding gauge, which has a sensor. This sensor is attached to the tube, and this tube is attached to a gear system and a pointer on a scale. This sensor is sensitive to pressure and volume. This is why we have 2 boarding gauge, for measurement of temperature and other measuring of volume correlated to the temperature. Now we can come to what we call electrical technique of temperature measurement. We have first 3 types. Resistance thermometer is made of platinum. Platinum increases its resistance by heat, as you can see, and it has an ammeter and a battery for a source of electricity. This ammeter is measured directly in temperature. So whenever the ammeter is changed directly into pressure, or we can use, as we will mention later, the method of Weston bridge, which is a bridge made of resistors, where we put the one we want to identify in it, and then we can record the resistor. The thermistor is a small bead of material made of oxides of metal. These are changed by, of course, these metals are changed by the temperature, heat, and the spread is exponential, as you can see. Sometimes some types of thermometer can also utilize the increase of resistance by heat. The bad thing about it that it is very difficult to be calibrated because heating from sterilization can affect it. But the nice thing is that it can be created in a very small bead where we can measure the cardiac output. The third one is the thermocouple based on the Seebeck effect. This means that whenever two metals are attached to each other, here we use a copper and a constant 10. Constant 10 is an alloy of copper and nickel. Whenever they are attached to each other at a reference point, it creates a voltage. So we have 2 points for the circuit to be complete. We have a measuring point and a reference point. You see, this reference point, of course, is adjusted electronically to be kept at a constant temperature. And this is the graph showing how much it is being increased by temperature. Notice that there is, it begins not from zero because this reference connection creates this difference in temperature. A clinical application, of course, as we said, for mercury thermometer are easy to be broken in the theater, and they take a long time to be equilibrated. Esophageal temperature, of course, we use the lower third of the esophagus to so that we will be affected by the respiration with an inspiration or expiration. So whenever I put in the lower part of the esophagus, gives me an accurate results. The nasal temperature, of course, it's a fluctuation during inspiration and expiration can be used to measure the respiratory rate, or it can be electronically processed. The nose, of course, may be used as a sort of measuring temperature. Instead, because of course the mouth could be occupied by the endotracheal tube. The radiant rays of the patient's skin can be recorded by a special camera. This is called thermography, and it gives an indication of the vascularity of the area, whether there is abnormal vasculature or tumors. Body temperature, of course, human, like other mammals and birds, are called homeothermic. Homeothermic means that they keep the temperature at a control range. This is the range of the human being, whatever the change of the temperature outside, of course, to keep the proper enzymatic reaction in the body. Slight variation, of course, occurs during circadian in the morning and at night, and during, of course, the menstrual cycle. And of course, whenever I perform exercise, the temperature can increase up to 2 degrees Celsius. Of course, the central core, we call the central core, is the central part made of variation. It's found in the brain, thorax and abdominal organs, and then some other deep tissues. And we have a shell one, which is in the area of 2 to 5 centimeters outside this core one. This temperature is range between 32 to 35. This is the difference with the core and peripheral temperature. 2/3 of the heat is present in the core, and 1/3 present the shell area. The core temperature recording is a balance between the production of heat in the core and the loss through the surface area. This is the equation to estimate the temperature of the human being. We multiply this figure by the core temperature by this figure, and lastly by the average skin temperature. Another method to measure the temperature is, as you can see, the infrared ear or the tympanic membrane thermometers. These are thermometers present in the external ear, where they collimate the infrared rays, which is one of the wavelengths of the spectrum of light. And they are collected by a tube. This tube is nearby the tympanic membrane. So this is the one that is measuring the external ear. And we have another one which is goes through the tympanic membrane, touching the tympanic membrane to measure the core temperature. Of course, there is a liability for it to perforate the tympanic membrane. We use what we call the 2 types of sensors. We have the pyroelectric, means pyro, of course, heat, and electric means electricity. And we have the other one, which is the thermopile. The pyroelectric depends upon the ceramic crystals, crystalline materials. Crystalline materials has discharges on its surface. This charges undergo what we call a polarization. The polarization means the molecules are separated from each other, and polarity means as if the molecule has two poles, because one of the poles is positive and the other pole is negative. For instance, water, of course, made of hydrogen and oxygen. Hydrogen, of course, is negative, and oxygen is positive. So as if the molecule has two poles. This is why we call polarity. This polarity, whenever an incidence rays fall on this ceramic crystal, its voltage is being changed. This is being recorded correlated to the temperature. So this is the mechanism of working of the pyroelectric. Of course, this ceramic crystals is made of made in capacitor shapes, and the change in the voltage by the temperature is being recorded, and it gives an electric output. It has what we call the shutter mechanism. Shutter opens and closes to save much of the energy. The second one, the thermopile. The thermopile is a couple of thermocouple, as we mentioned before. They are attached in parallel to give an accurate measurement of temperature. The good thing about this type of measurement is dependent upon whenever the incidence ray falls on the subject, it's not being absorbed to estimate the temperature. This is why it's in a speedy way. You don't have to absorb to measure temperature. So this is why the temperature recording is less than 5 seconds. The last slide gives us some physiological points. Heat production, of course, the human being, and as we said before, is the heat capacity of it is around 80 watt or 50 watt per square meter. And of course, we can increase this by food consumption, exercise, and so forth. There is no mechanism to decrease the high temperature whenever it occurs. But of course, we can lose our heat by shivering. We have minor shivering, of course, which cannot be appeared by the naked eye. This is recorded by the electromyogram. Shivering can be high enough to increase this figure 5-fold. You see, heat loss, which is very important. Heat loss is in the human being is in the form of 4 types. Radiation 40%, convection 30%, 20% evaporation, and respiration around 10%. 8 of respiration, 8% is used for evaporation of water for the humidification of the dry gas, and 2%, I'm sorry, is used to heat the air. So these are being taken from the mucous membrane of the human being. This is why it takes off temperature. So these are the 4 types. Of course, conduction is not very important regarding heat loss in the human being. Of course, conduction needs a good materials and some crystals to be in a good shape for conduction. The radiation is made of any hot object emits radiation. The spectrum of the wavelengths, predominantly the infrared region, carrying heat with it. Heat energy has been taken, causing cooling. 2 objects which are not in contact. So these 2 objects can transfer this heat according, of course, of which is more hot. And this transfer, of course, is affected by the surrounding. So the surroundings, whenever it's hot, it makes the situation different whenever it's cold. Space blankets, which is adjusted to, which is put as a shiny reflecting metallized plastic foil, is being put on the patient to decrease the heat loss by the radiation, but carries the risk of electrical shock and burns. Convection, as you can see, it is the air nearby the hot object of the human being. It is heated by this hot temperature of the human being, and whenever this area is being heated, it becomes less dense and raises and comes nearby another area of air comes nearby and takes more heat and so forth. Surface of evaporation, of course, from the skin. Of course, it depends upon the surface of the skin, and of course, in the sweating definitely increase the rate of heat loss. This is why sometimes we use clothes. Clothes, apart of decreasing surface area, is also traps air, and trapping air makes an insulator. Of course, fat is relatively a vascular insulator. And we have the last one is the respiratory components of heat loss. As we said before, respiration loses around 10% of the total heat loss. 8% to humidify the dry gases, especially anesthetic gases, and 2% and 2%. Slide will show that now come the Sorry. So this loss, which was the last one, by respiration, 10% to heat the gases, and 8% to humidify the gases. Response, of course, changes in the environmental temperature depends upon the skin receptors and the hypothalamic receptors, which is affected by the blood reaching it. Of course, the vascular tone of the human being can affect whenever there is mild changes in the environment, and whenever this changes is major, cooling can be controlled by shivering. Of course, we must remember sweating and vasodilatation. All these are measures to control the human body temperature, whatever its increase or decrease. Of course, we never forget the control of the cerebral cortex on such situation. Behavior changes. This is by the capability of the human being, not present children, to wear clothes and change their position. Hypothermia, which is common under anesthesia and not much appreciated by surgeon. It's affected, of course, anesthesia definitely affects the thermoregulator center, and most anesthetic cause vasodilatation. All these are methods for heat loss. And of course, the exposed high area of the surgery is liable for the patient to lose heat, and the ventilation, the rapid air movements of the ventilation, not from the air condition, is capable to take too much air from the human surrounding the human being, and will help in decreasing temperature and hypothermia. So in prolonged surgery, you must consider the core temperature for hypothermia, and you ought to warm the blood, transfusion blood, and humidified inspired gas. Thank you very much. Wassalamu alaikum wa rahmatullah wa barakatuh. Slide will show that